So we're going to spend some more time on 10.4. And remember, 10.4 is all about the different types of angles involving a circle, okay? And when we're dealing with angles and circles, what's the thing we're really, really going to be like thinking about, focusing on?
We're going to focus on where the vertex is located.
Okay, so the location of the vertex. So I'm going to make a little note up here. So it's really all about that location of the vertex. So let's kind of do a quick recap.
Okay. So like when the vertex was on the circle.
Okay, so on the circle.
Then, so if you have an inscribed angle, it's going to be half of the measure of its intercepted arc.
And it doesn't have to actually be inscribed angle. It could be an angle that's formed
true.
by a
tangent
and a secant. So,
yes, absolutely.
So as long as it's on, it's half of the arc. All right. Another one was, what if it's at the center?
If it's at the center, then it is the arc.
It is the arc. Okay. And actually, you know what? I'm going to change instead of the arrow. I'm going to put equals.
Yeah.
Because that's really what it is. Okay. Now, what's another one?
So just inside the circle. Inside the circle, it's going to be half of the sum of the arcs. And when we say the arcs, we're talking about its intercepted arc and its vertical angles arc.
And I'm going to put that in parentheses because you're taking half of that sum. So
right.
just kind of keep that in mind. All right. And the last scenario was?
If it's outside the circle, then it's going to be half of the difference of the arcs. And again, that's the larger arc minus the smaller arc, but the two intercepted arcs.
Okay, so this is a good kind of reference to kind of think about, okay? Mm-hmm. So here's the deal. The question said, find the possible value or values of x. So this is one where you could get a couple different answers depending on what you're dealing with, okay?
Okay.
So again, because it says value or values, you could have one or you could have more value. All right. Now I'm looking, and I noticed x actually represents what?
It represents the arc.
The arc CD or CB. Sorry.
CB.
Now we don't know that, so let's focus on what we do know. Okay. So what are the things that we do know?
All right. We're given two angles. One is an angle that's inside the circle.
Okay.
And one is an angle that's outside the circle.
Okay, and they're probably given for a reason.
Probably.
Okay. So, what are we thinking here?
Well, I'm thinking that first of all, the angle that's inside the circle, it's not really even associated with that arc at all.
I love that you said that. Because it's really associated with arc AC and DB.
Right.
So, feed off of that for me.
Well, I'm just thinking that I also know that angle B, whatever that vertex is, the 120 degrees, and the one that's going along with the arc that we're looking at are a linear pair.
Okay, so right here, what she's talking about is this angle here and this angle here. These are a linear pair. And what do we know about linear pairs?
That they add up to be 180.
So then that means this has to be...
It has to be 60.
Okay, and I like that you started there. What does this have to do with the problem? Well, this is not related to that one, but now this angle is related to that one, right?
Right.
Okay, so here's the deal. Let's keep going off of that.
Okay.
This angle is located, the vertex is where?
Inside the circle.
So if it's inside, it's half of the sum of its arcs. Now, what are the arcs that are involved with the angle 60?
The X and then the arc AD.
Now, we don't know this and we don't know this.
Right.
So we technically have two unknowns. So we know this is X. Let's label this
maybe Y.
Y. Okay. So we know that the inside angle, or an angle that the vertex is inside, you take half of its sum. All right, so that angle 60, is equal to half of what sum?
The X plus Y.
Okay.
Okay.
Now, here's the issue I'm seeing. I see an equation with two unknowns. So that means I need another equation, right? But we have another piece of information. This angle that's outside. So.
Oh, I see. Okay, because now we know that 15 degrees is equal to half of the difference of the two arcs.
And notice the two arcs that are associated with the 15
are still X and Y.
Are also X and Y. Okay, so they have that common arcs, intercepted arcs. So that 15 is half of the
X minus Y. So this has to be a system of equations because I can't even just find one first and then use that to help me find something else. They both have the same unknowns.
Mm-hmm, exactly.
So we've got two equations with the same two variables. We've got a system.
We have a system. So I'll make a little note off to this side. Okay, and we've seen this more recently.
Yeah.
Now, I see something that could be kind of convenient, right? to solve this system, right, I could distribute that half through, or I could just get rid of a half. How do I get rid of a half?
Multiply both sides by 2.
So if I multiply each side by 2, and I'm not going to multiply inside here. I've seen some people do that recently. So I'm going to multiply this by 2, this by 2. That cancels that out, but I got to do it to the other side, right?
Right.
So I'm going to multiply each side by 2. So this equation ends up being 120 equals x plus y. This one becomes
30 equals x minus y. And guys, keep in mind the reason that we don't distribute that 2 through each of those x and y inside the parentheses is because right now that 1/2 has that 2. So really when we distribute the 1, it's getting that 2 too. Otherwise you're double distributing.
Otherwise you're changing the value of the
you are.
equation. Okay, it won't mean the same thing. Now, system can be solved. We know there's really 3 different ways, but we focus on substitution and elimination. To me, what would be, and I know Ms. Hogravy would be feeling the same way, what would be the most convenient method?
Oh my goodness, use elimination because it's set up for it already. We have standard form and we already have opposites.
These are already opposite coefficients, so let's just go ahead and combine. So this is going to be 150. Now be careful.
Equals 2x.
Yes.
I know we'll have people that will just want to say x.
Okay, x plus x is 2x, and then these cancel out.
Right.
So then what's x going to equal?
X is going to be 75.
And what did the question ask?
What's x? So really we're done there. We didn't even have to find our y. We needed to make a y in order to be able to solve for the x, but we don't need to solve to find what y is.
Now,
too.
something that might be kind of helpful is, okay, let's just double check it's right. So if this is 75, what's y going to be? Well, if I go back, I could go back to one of these original, or here, I could go back here.
Okay.
If I put 75 in for x, subtract that from 120. Why don't you do that real quick for me?
So like 120 minus the 75 is going to give us a 45.
Okay, so if we double check this, remember these two added together, and then a half of that should get you 60.
And it does because it'd be 120 when we divide by the...
And then if I subtract these, right, that gets you 30, and divide that in half, that's going to be 15, so it works out.
Yep.
Okay?
Perfect.
So again, knowing this is huge, but also a little bit of algebra. This is really an algebraic problem once you get it set up.
And notice, guys, we had to make another variable in this problem. You're going to have to do that sometimes on some of these problems that require maybe a little bit more to be able to get there. All right, this next one says find the possible values of x. And as you look at this problem, notice that we have x's in all of these degrees.
Okay.
Some of them are arcs, some of them are angles. Tell me what you're thinking here. First of all, what do you see?
Well, the first thing I notice, because I'm dealing with angles and arcs involving a circle, I think about where the location of the vertex. And I notice the angle that you're dealing with is inside, right? So I know that I'm going to do the half of the sum of those arcs. But here's my issue. The angle that's given is not really associated with the 2 arcs that are given.
Right.
Okay? So I'm going to kind of go back, thinking back to that last problem, and Ms. Hogravy had us find the linear pair to that angle. So like that one was 120, we found it, just subtract from 180 and got 60. Now, here's the dilemma. That angle that's given is 12x. That's not an actual measurement. We don't know what x is. But we know its linear pair is 180 minus the 12x.
Right.
Which is, again, those add up to 180.
And it's okay to have an expression, and that obviously it is because we have an expression in all of these pieces
Exactly.
right now. Okay. Now, I love that you did that because we need to really be looking at this angle to help us when we're looking with the 2 arcs that we're given.
Okay.
Okay.
All right, so here's what I'm thinking. I know that the angle that's inside, so I'm going to write that 180 equal or minus 12x is equal to, now instead of doing half the sum, I'm going to do it a little bit different. Can we do the sum and then divide by 2?
Sure.
Okay, let's try that just to show it still works. So we're going to add the 3x plus 8 plus 7x plus 12, and we're going to just divide by 2. Just to show you that you could set it up
Half
this
of
way.
it is divided by 2.
Exactly.
Okay.
Some of you like this better, some don't really care. All right, so I can't really do anything on the left side
But
yet.
at least we do just have one variable.
So I'm just going to say 180 minus 12x equals, and I'm just going to combine everything up top. So that's going to be a 10x, and that's going to be a 20.
Ooh, those are both pretty easily divisible by 2.
So I could divide that expression on the right by 2 and get 5x plus 10. Now, could I also multiply each side by 2?
Absolutely. In fact, if you wanted to even make it a proportion and cross multiply, you could. There's lots of ways to do this problem.
Yeah. Okay, so then it's just a matter of getting x by itself, right?
Right.
So let's add 12x.
Okay.
So I'm going to get a 17x on that side. And then I'm going to subtract the 10, so I get 170. And then divide by 17, and I get x equals 10.
Awesome. Now, is that what they asked us to find, was just x?
It said find the possible value or values of x.
So there we're done. If they had asked for an arc or if they'd asked for an angle, make sure that you read the directions to see what you're finding.
And again, you guys could check by putting it back in, finding the arcs and angles. Again, this is all just for checking if you want to do it.
Yes.
All right, next one. Notice the directions are exactly the same. Find the possible value or values of x. All right, so talk to me about what you're seeing, Miss Hochgraby.
All right, well, I'm seeing where the two lines are crossing, the one tangent and the one secant. They're forming an angle. In fact, they're forming 4 angles that all have the vertex on the circle.
Okay, so when we're thinking on, what are we thinking?
We're thinking that it's just half of the intercepted arc.
All right.
Now, I'm looking at where the angle that they've given me, this 160 minus 9x, that's not really located anywhere that's in relationship to the intercepted arc that they've given us.
Because it really doesn't even have an intercepted
It doesn't. Now, it's a vertical angle with another arc. So I could go about this a couple ways. I could say, well, instead of this 2x squared plus 180, I could say the other part of that would be 360 minus our 2x squared plus 80. I'm thinking that's more work than I even want to do.
Okay.
So I'm thinking that, especially since that's got an x squared in it, I'm looking, though, at, again, forming a linear pair with the angle that they've given us.
I'm going to make a little note because this has happened now the 3rd time. All right? Keep in mind, if the arc and the angles that you're dealing with are not directly associated, you could use linear pairs. I like that you said even vertical angles. This one, just like the last one, if I could find the linear pair of this one, so if I could represent that angle, I can then associate it with that. Okay, hopefully everybody's seeing that. Now, what do we know about linear pairs again?
They add up to be 180.
So basically, to find this angle right here,
I'm going to take 180 minus the whole quantity.
Now, to show that, I'm going to put the whole quantity in parentheses. Now, when I do that, I'm going to do basically 180 minus the 160, but then I'm subtracting off a negative 9x, which becomes
a plus 9. So make sure when you're subtracting a quantity, you're distributing that negative sign through each piece.
So this angle ends up being
20 plus 9x.
Okay, so I just kind of showed that off to the side so you could kind of see where that's coming from. All right. Keep us going.
Okay, well, now I can go ahead and say that that angle, that 20 plus 9x, is equal to half of that intercepted arc, the 2x squared plus 80. And now here's one where I'm going to go ahead and just take half of each of those because half of the 2x is just going to be a 1x squared. Sorry, half of 2x squared will be a 1x squared, and half of the 80 will be a 40. And that way I only have 1x squared, which might be helpful because this looks like a quadratic.
And I like that you did that because, and guys, again, the reason why she did that is these are both divisible by 2. So you might as well do that, okay? Right. You could multiply each side by 2, but this makes it easy. Now, you said something I want to hit on again. She said the word, I don't know if you caught it, quadratic. I know I heard it. Loud and clear. Now, what gives it away that's a quadratic?
Because we have an x squared in there. And anytime you've got a term that's got an x squared is your largest exponent, that's going to be a quadratic equation.
You have an x squared, or if you even have a 3x squared. Basically, if you see an exponent of 2, that's your largest degree, that's a quadratic. Now, usually when you see a quadratic, that means you're going to get how many solutions?
2 solutions.
All right, so I'm going to make a little note here. Now.
Not always. Sometimes there's just one. Sometimes there's none. We'll see.
Okay, so here's the deal. I see an x squared, but I'm also seeing, and this is where it kind of limits how we do this, I also see a term that has an x.
Yeah.
So I can't just get the x squared by itself
and take a square root.
No. I can't do that.
But
so
what can we do? We could set the whole thing equal to 0.
Okay, get it all equal to 0. So we're going to try to get it equal to 0. Basically, move everything to one side.
Right, and I want to keep x squared positive. So I'm going to go ahead and subtract my 20 and subtract my 9x.
So I'm going to get 0 equals x squared minus 9x. And if I subtract 20 from here, I get a positive 20.
Right. Okay, so to solve a quadratic equation, we've learned methods in Algebra 1. Hopefully we remember some of them. I am thinking we could solve by factoring. We could solve by quadratic formula. Those are usually two of our easier methods to probably remember and use. And honestly, either one would be pretty easy on this one from what I can tell. Because this does look like it's going to be factorable. I can think of some factors of 20 that would add to give me my -9.
Okay, I'm jotting this down real quick.
Yeah, I think that's a good idea.
We haven't solved quadratic. I mean, we have seen them, and you guys saw it like literally a ton last year.
Yeah,
right?
and a ton on every challenge question. But these are always the ones that people tend to skip.
Okay, so solving a quadratic, again, you want to get it equal to 0 if you have x squared and an x term. You could use the quadratic formula, all right? And then the method that Ms. Hoker be suggesting is using by factoring, and that's what we're going to kind of do. And the reason why, what really is convenient is that x squared has a coefficient of 1, okay?
Right.
So it's pretty easy, again, to find factors, all right? And so we're finding factor pairs of what number again?
Factors of 20.
That,
And again, we can do this because it's just a 1x squared. Otherwise, you're going to have to take that leading coefficient times the constant.
yeah, it's going to be
It gets a little
more
more work. So factors of 20 that will add to give me my middle term, my -9.
So you want factor pairs of that 20, that constant, that add up to that middle term, -9.
Yeah.
Okay?
So I'm thinking factors of 20, like 4 and 5. They multiply to give me my 20, and if they were both negative,
Do that multiply to
they
get
still multiply
positive?
to give me my +20, but then they would also add to give me my -9.
Okay, so what is factoring going to look like? It's going to be like a binomial times a binomial, those little parentheses. So it becomes
An x -4 and an x -5. So each of those factors we're just putting into the parentheses with the x.
And guys, this is something we talked about recently. When you FOIL through, it's going to end up with this quadratic, okay? All right, now how do you actually solve it now?
Well, to solve is when we actually set each one of those factors equal to 0.
So this will equal 0. This will equal 0.
Right. And just a reminder, because if you think about it just logically for a minute, if that whole term was 0, so like if I put a 4 in place of x there, 4 minus 4 is going to make that term 0. 0 times anything will equal 0.
That's why you want one of these, only one of these really needs to be 0, but either one could. Okay,
Right.
so that's why either one works. All right, so I went ahead and solved and I got x equals 4 and x equals 5. All right, now it said find the possible value or values of x. Now, x is not an actual angle measure or an actual arc measure, so you want to make sure you check to make sure that it works, okay?
Right.
So if I put 4 in for x here, all right, I'm going to get
I'm going to get a 2 times 16 plus 1 plus 80. That's going to give us 112.
Okay. And then if I put 4 in here.
So that's going to be our 20 plus
36.
That is going to give us a 56.
And this is half of that. So
Right.
that works. If I check 5, it's going to still work as well. Okay. So this is one where both of them actually work. All right, so we're going to circle both of those answers. Now, sometimes you'll see it written kind of as a set, like 4, 5, that little funky brackets, but we're not going to be concerned about that, okay? So, again, good recap of quadratic, guys. Again, notice the only really geometry behind it was a linear pair and then setting up the equation. The rest of this stuff is all last year.
And just in case you're not loving the factoring idea, we're going to go ahead and write the quadratic formula on that page too. So that way you guys
glad
can
you brought
have
that
that. Just because that's always going to work too. So it's the opposite of b plus or minus the square root of b squared minus 4ac all over 2a.
You guys right,
And
remember this.
just in case you've forgotten, the a, the b, and the c, as long as your equation is in standard form, so going back to that x squared minus 9x plus 20, then the coefficient of whatever the x squared term is your a, coefficient of just the x term is your b, and the constant is your c.
And this is standard form, so I kind of wrote that here. So the A, the B, the C, and you just substitute in, okay?
Okay. Sounds good. Now, next one. Find the measure of angle 1. Notice angle 1 is located where?
It is actually outside.
So we know a relationship there that we can be using.
It's going to be half the difference of its intercepted arcs.
All right. Now look at this picture.
Okay, so I'm seeing, I'm going to first talk about angle 1. Angle 1 is intercepted arcs are AB and arc ADB, those two there. Now, so I might be thinking, okay, I have 2 unknowns, but I also have angle 1 is an unknown. So I technically have 3 unknowns.
So I can't do anything yet.
Okay, but here's what I'm thinking. I'm noticing they are giving us something. They have to give you something. And they're giving you an angle that's actually vertexes on the circle. That angle D is 64 degrees. And I know, since it's on the circle, it's half of its arc. Okay, so it's half of arc AB. So to get arc AB, I'm just going to double 64. So arc AB ends up being 64 times, I'm going to just double check, 128.
Yeah.
Okay. Which is good because arc AB is one of the intercepted arcs of angle 1, right?
And it is. Now, there's something else that's kind of special about this picture, though.
Because the angle 1 is formed by 2 tangents, the 2 arcs that are formed together make up the whole circle.
They do.
So that arc AB and arc ADB makes 360. So I could technically find arc ADB by taking 360 minus 128, and I get a total of 232.
Love it.
And notice how she's labeling that picture, guys, right? That's helpful, right? I know that a lot of you don't like to redraw the picture, but it's helpful to kind of redraw it and see it if you can't label it on there, okay?
Right. All right, so now, do we have enough information now to
We
talk about
actually
angle
do, because angle 1 is half of its difference of the 2 arcs, and its 2 arcs are 232 minus the 128.
Yeah. So notice how she did that. She really started with the information that we are given. That was the only thing given in this whole picture. That allowed us to find 1 arc. But because we know that those 2 arcs together make up that entire circle, it's easy then to find that second arc, and now we can do half that difference. All right, and what do we end up with for the measure of angle 1?
Okay, it's going to be a half of the 104, which ends up being 52.
And that's what they've asked us to find is the measure of angle 1. So
Okay.
we're good to go.
All right, last one. Another one that says finding the measure of angle 1. So let's first start there. What do we know about angle 1?
Angle 1 is located outside the circle.
So we're thinking outside. All right. Now, to find angle 1, we're going to have to find half of the difference of its 2 arcs. What are the 2 arcs that angle 1 is dealing with?
It's dealing with arc DB, which they've given us.
Okay, that's good.
And arc AC, which we don't have.
So our first goal is probably to find arc AC, right?
Probably would be a good idea. Yes.
Okay. So let's look at the picture and what else are they giving us?
Now,
Because they're giving us stuff for a reason.
They're giving us 2 other arcs that aren't really associated with this angle, but I do notice that all of the arcs that they've given us, minus that one piece that we don't know, make up the whole circle.
Okay.
So if I go ahead and actually take 360 and I take away all those other arcs, that should leave me with just the remaining arc
So if I
AC.
take 360 and I subtract off the sum of those arcs that are given, all right? So when I do that,
then I end up with 5.
so that arc AC is 5 degrees,
Right.
okay? So now how do I find angle 1?
So to find the measure of angle 1, I'm going to do half of the difference of those 2 arcs, so 85 minus 5. So I'm going to do half of 80, which is going to give me 40.
So those last 2, notice, weren't really like specific quadratics or systems. It was just using the pieces that they give us and finding missing pieces based on the stuff that they're given. So
Yep, be prepared to do that tomorrow.